the possible might go beyond what evolution has been showing to be able to do. And one of our active areas of research that is very ambitious, and we're working a lot on them, has to do with collective intelligence, right? Some years ago, we proposed the idea that we could actually use synthetic biology to reanalyze the problem of how ant colonies, for example, behave. And in general, the problem of collective computation. Meaning what? And that's one of the projects we have. Imagine I can take a bacterium, manipulate the molecular machinery and the way the bacterium communicates with others in such a way that they behave like ants, right? That doesn't happen in nature, right? Bacteria do their own stuff. Could I use that so that they can solve, for example, the shortest path problem, finding out the shortest path to a given place? If possible, and we believe it's possible, it's plenty of things that we could do. And in the process of doing that, we have been finding out that there are ways of filling that big empty space that I was talking about yesterday, the space that evolution seems to be unable to, in a way, to search, but we might be able to do it, right? And opens the door for many interesting things. So you don't really need to have a central control system. In the second lecture, I'll try to convince you that it's probably the case, right? That plants, because of they don't need that, and they are extraordinarily well adapted in different ways, right? Might not have anything like brains or intelligence. So, Physarum, plants, brains, ants, how do we put this together? And the idea, still work in progress, right, is to create what we call a morphospace, a space of possibilities. In this particular example that we used some years ago, I used 3 axes. The vertical axis is how important is development. Development is very important. Nature constructs things, right? You have embryos that develop and get into complex architectures. In the axis, a horizontal axis is the liquid to solid, right? The state of matter that we have. And in the other axis is how complex is your cognition? How complex are your decision making, and how diverse is the way you actually sense and respond to the environment? We locate things here in relative positions, okay? For example, organs are kind of simple cognitive systems, right? Or we could put, they are the outcome of development. They might be just responding to simple signals, or they might involve feedbacks that are more complex. This is the artificial part of the story. Organs have a counterpart in bioengineering, which is organoids, right? Which opens the universe of possibilities that we will discuss in the second lecture. Of course, brains, and of course, you can see I put a single sphere here representing all solid neural networks, right? This is an oversimplification. The immune system, which is a system that can learn, where cells can have memories, where collectively you have phenomena that remind us a brain, right? But they are liquid, they move around, right? We are living in a very interesting time now where it seems that because of our understanding of these networks, we might actually fight cancer and other things in a very effective way. Ants, of course, I put ants in the middle between liquid and solid. High development, because an ant colony actually, if you look at how it generates, it comes from the queen, the first eggs, the first individuals. The structure that emerges in a totally predictable way and ends up into something that is the structure plus the colony that is inside, kind of a liquid system, right? The microbiome, the millions and millions of bacteria that we carry out that makes us something that is not anymore a single species. The idea that we are one species we have to abandon because we really are much more than that. The microbiome, we'll talk about that also in the second lecture, has been co-evolving with us. The more we know, the more clear it is that many diseases we couldn't understand very well how they work are connected with the microbiome. And the great thing is that we can intervene, change the microbiome, and maybe fight those diseases, right? And this microbiome interacts with the immune system and with the brain, right? which means that we have a lot of things at play. Physarum, somewhere also in the middle between liquid and solid, okay? And this is kind of the big picture. And I want to bring to your attention something that is quite visible. It's this big sphere that occupies a lot of space. This big sphere is what we say is a void in the morphospace, meaning that when you look at the natural world, you don't see anything there. Why is that? Because it's forbidden? Because evolution, for some reason, is unable to get there? That's a big question. For many of us, is an indication that is plenty of space to explore, and that if we are able to engineer things, we might go right there.